Assalamu alaikum students. Students, it's a derivation of the drift velocity which is very easy to understand. We are considering here a conductor in which the electrons are moving from right to left because we have connected the left side of this conductor to the positive terminal of the battery, and the right side of the conductor is connected to the negative terminal of the battery. So the direction of conventional current will be from left to right, that means here, which is shown already in the diagram. So that's why electrons will move from right to the left with a particular velocity v, and this velocity v is called the drift velocity, and the magnitude of this drift velocity is known as the drift speed. Now we want to find the relation between the current I and the drift speed of these electrons which are flowing into this conductor, okay, from right to left. So that's why we are considering here let n be the number of free electrons per unit volume. It is very important to understand that we are considering here the number of free electrons per unit volume. That means in unit volume there are n free electrons. If we consider the 2 times of the volume, they become 2n, and if we consider 3 times of the volume, they becomes 3n, and if we consider v volume, their quantity will be nv. Okay, so these electrons are traveling a distance x into this conductor from right to left. So that's why we can use here the simple equation of kinematics to find out that distance, because these electrons have the drift speed v, and they will take time to cover up that distance x. They will cover up a time t, that distance x. So distance can be calculated as x is equals to vt. Okay, because the distance traveled by the electrons is v and the cross-sectional area of the conductor is denoted by a, so the volume becomes now a into x. So it is the volume of the conductor in which the n free electrons are moving. So that's why if we are considering here the charge of electron is equals to E, so the total charge that covered distance x into the conductor, it is denoted by the capital Q, that is the total charge. So it will be NAX into E. ओके, क्योंकि AX जो है वो वॉल्यूम है, कवर्ड वॉल्यूम, तो टोटल नंबर ऑफ फ्री इलेक्ट्रॉन्स कितने होंगे? टोटल नंबर ऑफ फ्री इलेक्ट्रॉन्स होंगे N इंटू A इंटू एक्स, मतलब आप इन तीनों क्वांटिटीज़ को, इन दोनों क्वांटिटीज़ को मल्टीप्लाई कर देंगे N इंटू A इंटू एक्स टू फाइंड आउट द टोटल नंबर ऑफ फ्री इलेक्ट्रॉन्स इन वॉल्यूम AX. और अगर हम टोटल चार्ज फाइंड करने के लिए जाएंगे तो डेफिनेटली वी विल मल्टीप्लाई दिस क्वांटिटी बाय द चार्ज ऑफ इलेक्ट्रॉन, बिकॉज वी आर टॉकिंग अबाउट द electrons. So the total charge which is flowing into this conductor at distance x can be found out by NAX into E. So that's why according to the definition of current, we know that the rate of flow of charge is equals to current, and it can be calculated by the formula I is equals to Q over T, and the total charge is NAX into E, and the time is t, and we also know that t is equals to x over v according to the above formula which is written here, x is equals to vt. तो हम यहाँ पर t की जगह पे x over v सब्स्टिट्यूट कर देंगे. So x will be cancelled out by the x, and v, when we shift this v into the numerator, so it will multiply by the NAV. So it becomes I is equals to NAE into V, and if we make V as the subject, so this formula can be rearranged बाय आई ओवर एन ए ई। ठीक है स्टूडेंट्स, तो ये इसकी एक स्मॉल सी डेरिवेशन है और इसमें क्वांटिटीज़ जो हैं वो क्या क्या शो हो रही हैं वो मैंने डिफ़ाइन कर दी हैं आपको। तो अगर कोई प्रॉब्लम हो तो फिर पूछ लीजिएगा आप लोग। थैंक यू सो मच। अल्लाह हाफ़िज़।